Good evening, guys. Just give me a minute. Problem file transfer. Shall we get started?
Yes, sir.
So today we'll discuss dual nature and dual nature atoms and nuclei also. Okay, we'll see the problems that are based on. See, for dual nature, the problems are mostly based on which concept? They are based on the concept of photoelectric effect. So, what is the expression for photoelectric effect, guys? The amount of the energy that is there in the light is getting utilized for two things. What are they? One is to overcome the work function and to provide the necessary kinetic energy to the particles. Right? So the energy supplied is utilized for the work function and to supply sufficient amount of kinetic energy to the electrons that are getting ejected out. Right? So let us see what are all the values that are associated. So energy is equal to h nu, or this is also equal to hc by lambda. Similarly, momentum of photon is given as h divided by lambda. Right? Similarly, work function, it is the minimum amount of energy required to remove an electron from the metal surface. That is given as h nu naught, which is equal to hc by lambda naught. Then, kinetic energy of photoelectrons is given by Einstein's photoelectric equation as K max is equal to h nu minus w naught. Why is it so? Because if I take K max from here, K max will be equal to h nu minus w naught. Right? Similarly, if you take V naught to be the stopping potential to stop the electrons that are getting ejected out of the metal surface, then half m into V max square should be equal to E into V naught. Should be equal to E into V naught, where V naught is called as the stopping potential. Right? Next is the intensity of radiation. Intensity is basically defined as the amount of power radiated per unit area, or it can also be defined as the energy per unit area per unit time. Okay. So having all these values, tell me how to solve the first problem. What is the frequency of a photon whose energy is this much value? So E is equal to hc by lambda.
Equal to h nu itself.
Or else you can use h nu itself. Right? E is equal to h nu, which implies E is 66.3. 1 electron volt is 1.6 into 10 power minus 19 joule is equal to, this is 6.626 into 10 power minus 34 into nu. Right? Actually, we can make this as 6.63 also, so that calculations will be easy. So please solve this and tell me what is the frequency. I have a call. I'll just be back.
One 1.6 into 10 power 16.
Yeah, sorry, how much is that? 10 into 1.6 into 10 power minus 19 into 10 power 34 is equal to nu. So it will be 16 into 10 power 15 hertz. That is going to be the frequency. Or 1.6 into 10 power 16 hertz. Both are same. Right? It's a simple problem. Next. A light of wavelength 4950 angstrom is viewed as a continuous flow of photons. What is the energy of each photon in electron volt? So E is equal to hc by lambda. So E is equal to H is 6.6 into 10 power minus 34 into C is 3 into 10 power 8 divided by lambda is 4950 into 10 power minus 10. Right. So on calculating this, you will get the energy of each photon.
So
See, I
for
don't want.
EV, we needed EV, so we can multiply in denominator 1.6 into 10 power minus 10 in here.
Yeah, yeah. Akash, konjam mic durama poi pesra. There is so much of sound coming. Okay. 6 எது சொல்ற? Where do I need to multiply? இது வந்து ஜூல்ல இருக்குடா. கரெக்ட்டா?
Electron volt na new denominator 1.6 into 10 power minus 20.
Correct. 3 into 10 power 8 divided by 4950 into 10 power minus 10 into 1.6 into 10 power minus 19. Multiply with that so that this will give you in terms of electron volt. Okay, that calculation again, I'm leaving it to you. So answer will come out as 2.5 electron volt. Next. Monochromatic light of frequency 6 into 10 power 14 hertz is produced by a laser. The power emitted is equal to 2 into 10 power minus 3 watt. What is the energy of each photon? So E is equal to h nu, but they have given in terms of power. So power into time is what? Power into time is energy, or power divided by frequency is also energy, right? This can be written as power divided by frequency. So what is the value of power that is given? 2 into 10 power minus 3 divided by frequency is going to be 6 into 10 power 14. So this is going to be 0.33 into 10 power minus 17 joule. Okay. How many photons per second on average are emitted by the source? Remember, this is the energy of each photon. Right. So what can I write? Power is equal to the number of electrons emitted per second, right? The number of electrons emitted per second into E. So how did I write this? Energy of one photon is E. Energy of n photons will be n into E. So n into E divided by time will give me the total power. Correct?
Sir.
Tell me that.
Sir, but while calculating energy of each photon, you took P, no, sir. So that should be energy of 4.
Which one? Oh, this one, right? Yeah.
Yes, sir.
Actually, I should have not done that. Sorry. Correct. That power is the total power that is radiated. So energy is equal to h nu. H is already known, 6.6 into 10 power minus 34 into nu is 6 into 10 power 14. So the power emitted is for the total light. It is not for one photon. Correct. So 2 into 10 power minus 3 is equal to the number of electrons emitted per second. That's what they asked, no? Number of electrons emitted per second on average into what is the value of capital E that we calculated from here. So 6.6 into 6 will be
39.6.
3.96 into 10 power minus 20.
So 39.6.
Yeah, 39.6 into 10 power minus 20. So it will be 39.6 into 10 power minus 20. So calculate this value. N divided by T will be 2 into 10 power minus 3 divided by 39.6 into 10 power minus 20. Okay, these many electrons per second is the answer. Clear?
Sir.
So I hope you, tell me that.
Sir, if we take T to the left side, sir, it will become PT, no, sir. That is again energy, no, sir. Will it not get cancelled?
Per how many photons per second தான் கேட்டிருக்காங்கடா. So I should leave n by t like it is. They didn't ask the number
Okay,
of
sir.
electrons. They asked the number
Yes.
of electrons per time. Okay, see, sometimes number of electrons per time, they can say the rate at which the electrons are getting emitted also. Rate means something with respect to time. Understand that. Okay. So mark it as important. You can expect this kind of a question in MCQ. Next, a monochromatic source emitting light of wavelength 600 nanometer has a power of 66 watt. Calculate the number of photons emitted by the source in 2 minutes. This is the number of electrons. So P is equal to n divided by T into eta. So it is n divided by T into, can I write it as hc by lambda? So n will be equal to P into T divided by h into c, and you have a lambda in the numerator. So power is how much? 66. Time is 2 minutes, which is 120 seconds, into lambda is 600 nanometers. So 600 into 10 power minus 9, the whole divided by h is 6.6 into 10 power minus 34, into c is 3 into 10 power 8. So this should get cancelled 10 times. This should get cancelled 40. 400 into 600 into 10 power minus 9 into 10 power minus 8 into 10 power 34. So it should be 24 into 10 power 4 into 10 power minus 17 into 10 power 34.
Sir, 2.4 into 10 power minus 17.
2.4 into, you will not get 10 power minus 17. That is fractional part.
Oh, sorry. 17, not minus.
No, see here itself I'm getting 17. This 10 power 4 is there, no? It should be 10 power 21, no?
22, sir. 10 power 22.
2.4 into 10 power 22. 21 தான் வருது எனக்கு.
Sir, 24 into 10 power 21, 2.4 na 10 power 22.
Okay. 10 power 21.
Oh, got it, sir. Yes.
Good. Okay. 2.4 into 10 power 22. Fifth one. If 5% of energy supplied to an incandescent light bulb is radiated as visible light, how many visible light photons are emitted by 100-watt bulb? Assume wavelength of all visible photons to be 5,600 angstrom, given that h is equal to 6.625 into 10 power 24. Sorry, 10 power minus 34. So lambda, it is 5,600 angstrom. That is 5,600 into 10 power minus 10 meter. Right? 5% of the energy supplied by the incandescent bulb is radiated as visible light. So what is the total energy here? It is hc by lambda. How will we get? 6.625 into 10 power minus 34 into c is 3 into 10 power 8 divided by 5,600 into 10 power minus 10. So on calculating this, let's check what is the value we are getting. We will get the value as 3.5 into 10 power minus 19 joule. So 3.5 into 10 power minus 19 joule is going to be the energy.
Sir. Sir, they should have given the rate, no, sir. The rate of photons.
That's what we need to find, no? How many visible light photons are emitted by 100-watt bulb?
But like what we have to find? N or N by T?
Actually, we have to find N by T only. They should have given rate. How many visible light photons are emitted by 100-watt bulb per second? They should have asked this. Only then it makes sense because power is given. Had they given energy, then we could have calculated the number. So power is equal to energy per unit time. Correct? But here one thing to be understood is not all this energy is getting converted to visible light. Only 5% of it is getting converted to visible light. So how much should I write? 5 by 100 into 3.5 into 10 power minus 19. The whole divided by time I don't know, right? Multiplied with n. Right? That should be equal to the power. Power is 100. So 100 is equal to
Sir, time is 1, right? T.
they ask emitted, okay, per second, no? Per second, T can be 1. Did they say per second? That is what I'm wondering. How many visible light photons are emitted by 100-watt bulb per second? Okay, then I can take this to be 1. Then you will get the value of capital N itself. So 100 should be equal to 5 by 100 into 3.5 into 10 power minus 19 multiplied with N. So in our home, 10 power 4 divided by 5 into 3.5, and here you have 10 power 19. So these many electrons will come out. Okay, this part you can calculate, and answer should be 1.43 into 10 power 10. Okay.
Sir, how are they getting 10 power 10, sir?
I don't know. 10 power 10 is coming for them, no? Did we miss anything?
Sir, I'm getting 1.1 second, so 14 into 10 power 18.
No, 10 power 19, bro.
No, I told 14. No,
You're
so
getting
1.4 into 10 power 19.
14 into 10 power 18 is what you got. No? That is 1.4 into 10 power 19. No?
Yes, sir.
Okay. Next. The second set of problems that you have in this chapter are based on de Broglie wave, right? So when you calculate the kinetic energy is given as half mv square or p square divided by 2m, and momentum is also written as root of 2m into k. So what is de Broglie's wavelength? It is given as lambda is equal to h divided by p, or it is h by mv, or h divided by root 2m into k. Right. So de Broglie wavelength of an electron beam which is accelerated through a potential of b volts is given as 1.23 divided by square root of b. Okay, because you have root of 2m into k. In the place of k, you're going to substitute EV. When you substitute EV, you will get the answer as 1.23 divided by square root of v nanometer. (23rd). So what is the de Broglie wavelength associated with an electron? So mass of electron is 9.1 into 10 power minus 31 kilogram, accelerated through a potential difference of 100 volts. So lambda will be equal to 1.23 divided by square root of 100, and this is in terms of nanometer. So how much will be the answer? 1.23 divided by 10 nanometer, or 0.123 nanometer. That will be the answer. Got it? Calculate the momentum of photon associated with radiation of frequency 5 into 10 power 13 hertz. P is equal to mv. So how will you calculate the momentum? In this case, we can say, since we know that lambda is equal to h divided by p, it implies p is equal to h divided by lambda. H is 6.6 into 10 power minus 34. It is minus. Divided by lambda is how much? Lambda is equal to how much? C divided by F. So C into F. So 6.6 into 10 power minus 34 into F is 5 into 10 power 13. The whole divided by C is 3 into 10 power 8. Calculate this, that will give you the answer. So get the answer as 1.1 into 10 power minus 28 kilogram meter per second. Okay. Next. The kinetic energy of an electron orbiting in the first excited state of hydrogen atom is 3.4 electron volt. So kinetic energy is equal to 3.4 electron volt. Determine the wavelength. So lambda is equal to h divided by root of 2m into k. So 6.6 into 10 power minus 34 divided by square root of 2 into m is how much? 9.1 into 10 power minus 31 into k is how much? 3.4 into 10 power. Okay, 3.4 into, since it is an electron volt, you need to multiply it with 1.6 into 10 power minus 19. See, don't worry, you will not get this big calculation and all, but it is only for understanding the application of formula. Okay. So on solving this, you should get the answer as 6.63 into 10 power minus 10. Okay.
Sir?
Sorry, you're copying?
Yes, sir. Sir, the kinetic energy should be in joule, right?
That's what I converted to, because they gave an electron volt. 1 electron volt is 1.6 into 10 power minus 19.
Yes, sir. Like it can't be in EV, right? Like while calculating wavelength.
Sorry, can't be?
Sir, can you
Can't
show
be?
the solution? Just a second. Okay, sir. Got it.
Okay. The kinetic energy of a beam of electrons accelerated through a potential difference P equal the energy of photon of wavelength 5460 nanometer. Find the de Broglie wavelength associated with the beam of electrons. So lambda is equal to h divided by root of 2m into k. Beam of electron accelerated through potential difference. So kinetic energy is equal to hc by lambda. And so this is the lambda, hc by lambda is for the photon. Sorry, energy of the photon. Kinetic energy, so lambda of electron is equal to h divided by root of 2m into kinetic energy of electron. So this kinetic energy is equal to how much? H divided by root of 2m into this energy, that is hc by lambda p, right? So lambda of electron will be equal to square root of h into lambda p divided by square root of 2m into c. Okay. So substituting all the values, we need to calculate the wavelength associated with the beam of electrons.
Sir.
Tell me that.
Sir, but why did they give potential difference V?
Maybe not needed, right? It's not needed. Just give it.
Okay, sir.
Sir,
Ah,
sir, why can't we use like 1.227 by root V, where V is equal to energy of proton?
how will potential difference be equal to energy? The potential, you can't equate two different physical
Sir,
quantities.
they have given, right?
Aha. The first question, Gurujuko. Or potential difference. Through this, they have accelerated electrons. Okay, what is the energy of electrons EV here? Okay, this is the energy of electrons, and this energy is numerically equal to the kinetic energy of is numerically equal to the energy of each photon, which is hc by lambda. Means if you multiply E with V, that value will be numerically equal to hc by lambda. That is the meaning.
Oh, okay, sir.
But this EV is what is kinetic energy, no? That is why in the place of kinetic energy, I substituted this hc by lambda p. Got it?
Yes, sir. Got it.
Right. These are the set of problems that are associated with dual nature. Okay. The next set of questions you have is in atoms. In atoms, you have calculations only in two concepts. One is in the Rutherford's experiment, where you will calculate the distance of closest approach. Okay. That value will solve one problem. And then, according to the Bohr's concept, we know that we have problems based on calculating radius and energy. Okay. So what is the distance of closest approach when a 5 mega electron volt proton approaches a gold nucleus? So energy is equal to 5 into 10 power 6 into 1.9 into 10 power minus 19. Right. So what will you write the mathematical equation as? You will write this energy is equal to kz E square divided by R naught, where R naught is going to be the distance of closest approach. So actually what is happening? Kinetic energy is getting converted to the potential energy, right? Which implies 5 into 1.6 into 10 power minus 13 is equal to 9 into 10 power 9 into Z is for gold. What is the value of atomic number? It is 79 into E square, that is 1.6 into 10 power minus 19 square, the whole divided by R naught. So R naught is equal to 9 into 79 into 1.6 into 10 power minus 19, the whole square, into 10 power 9, the whole divided by 5 into 1.6 is 8. So 8 into 10 power minus 13. So on calculating this, you will get the required answer.
Sir, can you show the question? Okay, sir.
Yeah. See, these are all the impact parameter and all, you will not get a question. So next is problem based on this Bohr's theory. See, for Bohr's theory, you need to know one thing. Coulomb's force is equal to the centripetal force. Similarly, the angular momentum is quantized. MBR is equal to NH by 2 pi. Similarly, H nu is equal to En2 minus En1. And Rn is given as n square h square by 4 pi square mkz e square, or Rn is equal to 0.53 into n square divided by z. This can also be used. Okay. Similarly, energy of the electron in the nth orbit is given as minus 13.6 into z square divided by n square. And energy of the electron in the nth orbit is negative of kinetic energy, and potential energy is given as minus 2 times kinetic energy. Okay. So
Sir?
sometimes they'll give you potential energy and ask you to calculate kinetic energy. The relation is potential energy is equal to negative of 2 times kinetic energy.
Sir, why it is given like minus 13.6 by n square?
Yeah, Z is there, Z square. For hydrogen, they took it.
Okay.
Because all others are constant except Z and N. Similarly, the other set of questions you can get is to calculate the wave number. So wave number is equal to R into 1 by N1 square minus 1 by M2 square. This is what happens for the emission spectrum, where R is given as the Rydberg constant 1.097 into 10 power 7 into 1 by N1 square minus 1 by N2 square. Okay. Evaluate Rydberg's constant means you can take this expression. Okay. In that, you will put all the parameters and calculate the value, which comes out to be 1.097 into 10 power 7 meter inverse. Okay. That part I'm giving it to you.
Sir,
Tell me that.
sir, in the formula 13th, what is it?
That is time period.
Okay.
Taking of an nth electron.
Time taken by the electron to complete one revolution. Time period is basically distance by speed. So 2 pi r divided by speed, 2 pi rn divided by vn.
Yes, sir.
Velocity again, this not needed. I didn't take many problems based on radius. Okay, write down the formula for velocity also. Velocity is 2 pi k e square by nh. So 2 pi k e square divided by nh. So can I write this as 2 pi k e square divided by ch into n divided by, sorry, into c divided by n? So this 2 pi k e square divided by ch is what is called as alpha, which is also given a name called as fine structure constant. Okay. So fine structure constant is 0.0073, or that is 1 by 137. So calculate the velocity of electron in Bohr's first orbit of hydrogen atom. So anybody with the answer? The calculation is very big. Actually, you can remember that value. Velocity of the electron, the Bohr's first orbit of hydrogen. So what is the value of V, guys? It is 2 pi k E square divided by NH. You will put the value of N is equal to 1. So on substituting all these values, you will get the answer as 2.186 into 10 power 6 meter per second. Right. How many times does the electron go in the first orbit? In 1 second. So you can calculate the frequency as 1 by time period. So 1 divided by time period is given as 2 pi r divided by v. So this will be equal to v divided by 2 pi r. So in the place of v, you can substitute 2 pi k e square divided by h divided by 2 pi into r. You can substitute 0.53 into n square divided by z. Both are going to be 1. So 2 pi and 2 pi will get cancelled. So on calculating this, you will get the answer as 6.57 into 10 power 15 hertz. So these many revolutions it makes in 1 second. Okay. So this is also calculation based. Okay. So I'm just checking. We'll do nuclei, then we'll do some. I'll take some problems based on radius. Okay. So in nuclei chapter, right, you have problem based on Einstein's mass energy equivalent, that is E is equal to mc square, and one AMU is obviously defined as 1 by 12th of mass of a C12 atom. Then there is a problem based on calculating the radius of the nucleus, which is R is equal to R naught into A power 1 by 3, where A is the mass number of that particular atom, right? Similarly, the density of the nucleus is given as nuclear mass divided by nuclear volume. So mass of nucleus divided by 4 by 3 pi R cube. Okay. So these are all the values. Okay. Now express 16 milligram mass into equivalent energy. So how to convert it? We know that E is equal to mc square. So m is 16 into 10 power minus 3 into c is 3 into 10 power 8 the whole square. So 16 into 10 power minus 3 into 9 into 10 power 16. Right. So this will be the energy in terms of joules. So we want the energy in terms of electron volt. That will be 16 into 10 power minus 3 into 9 into 10 power 16 divided by 1.6 into 10 power minus 19. So this and this will get cancelled. It will be 90 into 10 power 29. Okay, which will be 9 into 10 power 30 electron volt. How many electron volts make up 1 joule? So 1 electron volt is 1.69 into 10 power minus 19 joule. So if at all you want to convert joule to electron volt, you're doing this 1 by 1.602, right? Instead of that, you can directly multiply it with 6.242 into 10 power 18. This also you can do. Okay. Next. Taking one atomic mass unit is equal to, so remember, one atomic mass is equivalent to 931.5 mega electron volt. So taking one atomic mass unit is equal to 931.5 mega electron volt. Calculate the mass of carbon atom. So mass of carbon atom is 12 AMU, right? So 12 into 1 AMU can be replaced with 1.65 into 10 power minus 27 kilogram. So here make a note of it. The 1 AMU is equivalent to 1.6 into 10 power minus 27 kilogram. So write that value and multiply, that will give you the required answer. So that will give you 1.98 into 10 power minus 26 kilogram. Okay, next. Not needed. The next set of problems are based on mass defect. So mass defect is given as, so how do you define the mass defect as this? Can you tell me? So mass defect is given as mass of theoretical minus mass of practical. Tell me.
Sir, your screen freezed.
Yes, sir. It's for me also.
Is it visible now?
Yes, sir.
Yes, sir.
Okay. So how is mass defect given as? It is Z times mass of neutron, right? Sorry. Z times mass of proton plus A minus Z times mass of neutron, right? Minus the actual mass that we calculated. So this is the theoretical value, this is the practical value. So theoretical value minus practical value is going to give you the mass defect. And this mass defect has the tendency of producing an equivalent amount of energy called as binding energy, which is given as delta M times C square. Okay, delta M times C square. Similarly, we'll calculate another parameter called as binding energy per nucleon. It is given as BE, binding energy per nucleon is divided by the mass number. Okay. So having all these values, let's see how to calculate the binding energy of an alpha particle in mega electron volt. So mass of proton is given as this much value, mass of neutron is this much, mass of helium nucleus is this much, 1 AMU is this much. So first calculate the mass defect. Delta M is equal to 2 Z times MP plus A minus Z times Mn. Z is 2 into mass of proton is 1.007825 plus A minus Z is 2 into mass of neutron is 1.008665. Right, this is delta M. So on calculating this, you should get the answer as 4.032980. So this much AMU. So if you want to calculate the binding energy, it is delta M into C square. Instead, what you can do is you can take this value. Oh, sorry, I calculated only this value. Z times MP plus A minus Z times Mn minus the theoretical mass of helium. Right, minus how much is the value? 4.002800. So how much will that value come to be? That value will come out to be 0.030180. 0.030180 AMU. So take this value 0.030180 and multiply it with 931.5. That will give you the required value of binding energy. Okay. So I hope you could understand. So whenever there is a question asked on binding energy, first calculate the mass defect. Once you get the mass defect in terms of AMU, replace the AMU with 931.5 mega electron volt. Right, this number will be as it is. 0.0308180 is going to be as it is. Multiply that with 931.5 and that will give you the required binding energy. The next set of problem that is possible is binding energy per nucleon. So calculate this value and divide it with the mass number. That will also give you the required answer. Okay. Next. There are problems based on calculating the Q value, nuclear fission and nuclear fusion. There also we are going to do the same thing. We'll calculate the mass defect and multiply it with C square. Right? If the mass defect is calculated in AMU, you will multiply with 931.5. Right? So having said this, observe how to solve this question. A nucleus with a mass number A is equal to 240. Right? A is equal to 240 and binding energy per nucleon to be 7.6 mega electron volts breaks into two fragments of mass number 120 with binding energy per nucleon to be 8.5 mega electron volt. Calculate the energy released. So energy released or absorbed is given as binding energy of product minus binding energy of reactants. So binding energy of product minus binding energy of reactant will give me the energy released. So binding energy of product is how much? 240 multiplied with 7.6 minus binding energy of reactant is how much? Oh, I took it in the reverse. It is broken into two fragments of mass number 120. So total mass number is going to be 240 only. 240 into 8.5. Okay, we'll get a negative value. The negative value indicates that the energy is released. So 240 into 7.6 minus 8.5 is going to be 0.9. So that will be 24 into 9, which is going to be 216 mega electron volt. There will be a negative sign. The negative sign indicates energy is released. Okay. Next. Calculate the energy released in the fusion reaction where binding energy of hydrogen is 2.23 mega electron volt and binding energy of helium is 7.73 mega electron volt. The same logic again. Energy released is equal to binding energy of products minus binding energy of reactants. So binding energy of product is binding energy of helium 32 minus binding energy of reactant is binding energy of H21, which is multiplied twice. For product we have neutron also, no? Plus binding energy of neutron minus 2 times binding energy of H21. So what is the binding energy of helium that is given? 7.73 plus binding energy of neutron is 0 minus 2 into what is the binding energy of H21? It is 2.23. Everything is in mega electron volt, right? Calculate this value, that will come out as 3.27 mega electron volt. Okay. So these are all the set of problems that are possible from dual nature atoms and nuclei. Is it clear till this point, guys? Is it clear? Can I have some response?
Yes, sir.
Yes, sir.
Okay.
Yes.
So good. So that's it from my side. Okay. I'll share some questions that are based on radius and energy. You can try solving them. Okay. So that's it. We can write
Thank
up.
you, sir.
Yeah.
Thank you, sir.